Usually when I do these videos, I try to do them without any kind of notes or outline or anything like that, because the object is to learn how to speak fluidly without a teleprompter kind of thing. But today's topic is very difficult, and so I'm cheating today. And I wrote myself a little doohickey here to remind myself of some of the things that I want to talk about. I'm still going to try to do this without this, but in case I need to cheat a little bit, I'll have this with me. Okay, so in the previous 6 videos, I argued that the universe had a finite past, and I need to make a clarification about something that I said in some of the previous videos. I used the term finite past and beginning of the universe interchangeably. It turns out that usually when William Lane Craig and people like that use the word beginnings to exist, what they mean is comes into existence. But that is not what I meant. When I said begins to exist, I meant the same thing as has a finite past. Now, what I'm going to argue today is I'm going to argue from the fact that the universe had a finite past to the conclusion that the universe came into existence. And I think this is an important step in the Kalam cosmological argument that a lot of apologists skip. Even William Lane Craig skips this when he presents this argument in public debates and talks and things like that, even in some of his more popular level books like On Guard. But strictly speaking, the fact that time has a finite past, or that the universe has a finite past, does not by itself show that the universe came into existence. There's more argument that needs to be made. And William Lane Craig recognizes this. And I wrote down a quote. This is from his book, Time and Eternity, on page 233. He said, strictly speaking, none of those arguments reached the conclusion, therefore time began to exist. And what he means by time begins to exist is that time came into existence. He's actually got this really kind of, in some of his written works, he analyzes this whole concept of begins to exist or comes into existence. And he has all kinds of criteria, and he has the arguments for those criteria. And that's something a lot of people aren't aware of, because this never comes up in like popular presentations. Most people out there who are aware of the Kalam cosmological argument get it from these popular level presentations or debates or things like that, where you just get these short summaries. You don't get the detailed version of it. But anyway, so the reason this is an issue is because actually what I think is the strongest argument against the Kalam cosmological argument is that it doesn't make sense to say that time came into existence, because that would assume that there was a state of affairs prior to the beginning of time in which the universe didn't exist. And since time is all of duration, it's incoherent to speak of a state of affairs occurring before time, because that assumes that there's a time that exists before time, which is a contradiction. So this is an issue. I mean, this is a potential defeater for the Kalam cosmological argument. But I think it can be shown, first of all, that it is conceivable that there could be a state of affairs in which nothing exists and then time begins. And so I want to use some thought experiments to explain why I think that is possible. And then 2, I want to try to make sense out of that, like on a number line. How would that work? Would that mean before or whatever? And then I want to make an argument showing that given the nature of space and time and the universe and everything, that it's in fact true that there must be a state of affairs in which the universe doesn't exist and then the universe comes into existence, in spite of however difficult that is to conceive. So let me start with just using a number line. On a number line, you would have 0 and then all the positive numbers after that. Now, what is the first number that comes after 0? If you think about that, there is no such number. Any number you can think of, there will be a number between 0 and that number. And so what mathematicians usually do is they'll speak of a limit, like if you have an equation that approaches infinity as a limit, then they'll say it's a, the limit as whatever reaches zero. Well, butchering that part, aren't I? Okay, another way to do it is to speak of intervals. So like you have closed intervals and open intervals. And a closed interval would be like, say, the interval between 0 and 1. If it's closed interval, they use square brackets, and that means that it's everything between 0 and 1, and it also includes 0 and 1. An open interval would you just use parentheses around 0 and 1, and you would say it's everything between 0 and 1, but does not include 0 and 1 themselves. And so I think that if you think about numbers like right next to 0, you would call that an infinitesimal, because there's no, look at it this way. Like imagine you've got a sheet of something that has no thickness at all. It has 2 dimensions. It has a length and a width, but it has no thickness at all. And you stack another one on top of that, and you stack another one on top of that. Well, if they have no dimension, they have no thickness, so they have no dimension in this third dimension, then no matter how many you stack on top of there, you're not gonna gain any thickness. And the same thing is true with points. A point on a number line has no dimension. And so if you take another point, you slide it up beside it, and then you slide another one up beside that, you can just keep sliding as many of those as you want, and it will not extend along the number line. And so really, you can think of 0 as being a boundary of a number line that, where 0 is the earliest extreme. You can think of this number line as a timeline, and 0 is the earliest extreme, and everything else comes after it. So the way I see it is you can think of 0 as being like the situation where it's timeless, and everything that comes after 0 is temporality. And so I would say that the universe is the open interval between 0 and infinity. And so to say that it's open means that the temporal aspect of reality is everything after 0, but it's not 0 itself. And 0 would be the atemporal state. So in this scenario, the 0 serves as a boundary. It's not strictly speaking before. I guess you can think of it in a sense as being before time, but it's really just a boundary of time, because if you think about it, that earliest moment of time, since that point has no dimension, then that earliest boundary of time is going to be right there at 0. So it's almost like, this is kind of hard to wrap my head around, but it's almost like the atemporal state and the temporal state exist at the same point. And yet one comes before the other. I don't know, it's kind of hard to think about. But the way I think of it is, I'm not trying to prove this at this point, I'm simply explaining how I see things, which I'm going to argue for in a minute. So I think of like the existence of God as being the closed interval from 0 to infinity. And that means that God exists at 0, which means God exists atemporally at 0, and then he initiates time. And so time is the open interval from 0 to infinity, and God is the closed interval from 0 to infinity. Okay, so let's let me use some thought experiments to try to make sense of this, and then after that I will explain why I think it's actually true. So just kind of imagine a world in which there is no time, that everything's just kind of frozen. There's no temporal dimension. And then just kind of conceive of time beginning. Just boom, time begins. To me, that's conceivable. Even though it may be hard to figure out how you plot that on a number line, it's still conceivable that something like that could happen. So I was just sitting here editing the video, and I don't know how I missed this because I looked straight at the notes, but I left out one of my thought experiments that I really wanted to include. And it's a thought experiment concerning motion. Imagine something sitting still on a line where it's sitting at 0, and then it begins to move. So how would you map its motion on the number line? Well, you would do it as the open interval from 0 out to however far it went. But it cannot have been in motion at 0. Even though it left 0, it wasn't in motion at 0, because at any point in time in which it's still at 0, that means that it hasn't moved. So at any point that it's in motion, that means that it has left 0. And so, yeah, there you have it. And so the same thing would be true with time. If you had an atemporal state and then time began, then time would have to be the open interval from 0 to however far time goes, infinity or whatever. And at the boundary, the boundary at 0 would have to be an atemporal state, and everything proceeds from that state. I explained this a lot more clearly in the blog post that I made, so I'll leave a link in the description to that. Here's another one. Imagine a situation in which, I saw this episode of The Twilight Zone when I was a kid, and this woman found this necklace in her garden, and she put the necklace on, and whenever she would say, "shut up," time would stop, and everybody around her would kind of freeze. She would keep moving, but everybody around her would freeze, and then she would say, "start talking," and time would start again. And my brother and I used to play this game when we were kids, where we would pretend to have that power, and we'd be going about doing whatever we wanted to do, and one of us would say, "shut up," and the other would have to freeze, and then we'd say, "start talking." And sometimes we'd like pick each other up and move each other somewhere. But anyway, so imagine if that actually happened, if time stopped and then started again. In reality, we wouldn't notice that anything had happened if that actually happened to us. But that would be a situation where time stops and then starts again. So that instantaneous moment in which time stops doesn't span any duration. And so you've got the past leading up to this point, which we can call the present, and then we've got the future proceeding from that point. But that point itself does not have any duration, which means that the past and the present kind of like practically touch. And yet there is this atemporal state between the past and the present in which time had stopped. And so you can think of the beginning of the universe, just think of that scenario where you got the past coming to a point, stopping, and then proceeding to the future. So just imagine that scenario, but erase the past in your mind, and now you've got this atemporal state followed by a temporal state. So that's just another thought experiment. Another thought experiment, I guess, black holes. According to relativity, time supposedly stops at the center, at the singularity of a black hole. Supposedly, there's this thing called Hawking radiation, and a black hole is not a permanent state of affairs because black holes can give off radiation and eventually they'll dissolve. And so if it's true that that time stops inside a black hole, then if a black hole dissolves, then that would be a situation in reality where you had an atemporal state that precedes a temporal state, because everything in the black hole becomes temporal eventually when it dissolves. So, but there's an imperfection in that scenario, which is that if you were to fall into a black hole, you would never. It may seem from an outside point of view that your clock had stopped, but from your point of view, time would not stop. Time would keep going on just like normal, and everything outside of the black hole would go by at an infinite speed or something like that. I don't know. Black holes are weird. Okay, let's see. So far, I still haven't looked at my cheat sheet, so I'm doing all right. I guess that's okay for thought experiments. Now let me make an argument for why I think that this is not only conceivable that there would be an atemporal state followed by a temporal state, but that it's actual. And the argument is this: let's imagine a scenario in which in which time stops tomorrow. So like everything just keeps going on like it is right now, except that tomorrow time stops. What should we expect to happen? What would that look like? Well, it seems to me one of two things would have to happen. Either we all freeze, like, they portray it in, those movies and TV shows and stuff where somebody freezes time and then starts time again or something. So either we all freeze or we all just poof out of existence. Now, I would argue that it's impossible for us to freeze like they portray in the movies and TV shows. And the reason is because of the nature of physical reality. Physical reality, when you look at it at the quantum level, it's all wavy. We've got these quantum fields that permeate all of space, and they're in a constant state of motion. And so it's impossible for material reality to be in a state of, motionlessness. You can't, quantum fields and electrons and things like that, they can't exist in a state of motionlessness. They have to wave. They have a wave property. And besides that, it would violate the Heisenberg uncertainty principle, because according to the Heisenberg uncertainty principle, there can't be a discrete momentum and velocity at the same time. And so if you kind of narrow down the velocity, then you're going to have an ambiguity about the momentum. And if you pinpoint the momentum, you're going to have an ambiguity about velocity. But if everything froze, then you would know the momentum and the velocity at the same time. So the Heisenberg uncertainty principle makes it impossible that time could be, or that matter and the universe and everything could be in a state of timelessness. So if we were to imagine a situation in which you're going forward in time and then time stops, well, then the universe would have to cease to exist. And it's not as if we could just reach an edge and then remain eternally there in temporality and motion and stuff, because if we're in motion, we're going to keep moving forward, but we're going to hit this wall in which, time can no longer move forward. And so time has to stop. And so when time does stop, there's going to have to be an atemporal state at the end of time. And so all you have to do is just reverse that, and then you get what we have at the beginning of time. If it were a situation where the universe existed in an atemporal state, like everything frozen and then began, then there would be no reason to think that the universe came into existence. If it existed in an atemporal state and then became temporal, then the universe would be eternal. Even though it had a finite past, it would still be eternal. But if the earliest state of reality were an atemporal state, and then temporality began and the universe began, well, that would be a situation where the universe came into existence. So just as at the end of time, the universe poofs out of existence, at the beginning of time, the universe would have to poof into existence. And so basically the argument is that if the universe is always temporal, if every state of the universe is a temporal state, then the universe had a finite past, then the universe would have to come into existence. But if the universe has a finite past and it has an atemporal state at the earliest extreme, then it did not come into existence. And since I am arguing that since the universe can only be temporal, it follows that it cannot exist in an atemporal state. And so since there is an atemporal state at the beginning of the universe, just as there would have to be at the end of the universe, it follows that the universe had to have come into existence. And that is all I can think of right now. So I'm going to take a peek at my cheat sheet here just to see if there's anything I missed. You know what? I think I covered everything. Good job, Sam. All right, so I have argued from the beginning of time. Oh, by the way, like I said earlier, William Lane Craig does address this in his book, Time and Eternity, towards the end of the book. He doesn't go into all this detail that I just went into. I went into all the stuff that I just told you is stuff I came up with because of thinking about this for years. Maybe it's wrong. I don't know. To me, it seems fairly certain, but you may disagree. But anyway, so up until now, I have argued that that the universe had a finite past, and that it therefore came into existence. And so the next thing I'm going to argue is we're going to talk about whether it had a cause or not, and I'm going to argue that it had to have had a cause if it came into existence. And I guess that's it for this video. Thanks for coming. Oh, there's one more thing I wanted to mention is that I'm going to post a link to I did a blog post on this, and the blog post is probably going to explain all this stuff more clearly than I did in this video. So, yeah, I'll have a link to that in the description.